Now that we have desurveyed our data and checked it in 3D visualization, we can proceed into compositing, because right now we desurveyed the raw assays, and usually we want to get the data to some consistent support for posterior use. So going into compositing, there are two main ways of performing compositing in RMSP. The first one is the run length compositing. So we're gonna call it run length, and I missed the T here, comps. And for that, we are gonna use the get underscore run, and then I can press tab, and that's the only function that comes up. That's the get run length intervals. So for the get run length intervals, this is the most basic compositing function. What it does is just to create uniform intervals for our interval data. So if I look into the arguments here, the most important ones would be the interval data. And notice that here I can actually provide a list of interval data. So I don't necessarily have to have my interval data merged beforehand like we did. Sometimes it's useful to have that merged, but for this step, we do not need that. So actually I will demonstrate that by creating my run length intervals with just my intervals that are not merged. And the second argument here is the composite length. So the whole purpose of run length intervals is to create equal size composites. In this case, we're going to use 5 meters. So I can check the result of this function by looking to some of the data. In this particular case, I'm going to be looking at the tail, and I'm going to look at the last 15 records. So if I run this, I can see now the intervals that has been composited. You can see that at the very end of the last drill hole, of course, the composite is going to be trimmed by the end of the drill hole. But other than that, all the composites, they are 5 meters. So alternatively, the other approach that we have is the split intervals. So if you want to split intervals by domains, then you can use this function. So let's say is split comps is equals to RMSP dot get is split, and then I can press tab. That's the only function that comes up. So that's the get split intervals. So what we need for split intervals are our interval data. We could use a list like I did in here, or we can use our merged interval data. So just to show a different approach, I'm gonna use my merged in assay, and also we'll create 5 meter composites. But we are gonna be providing a categorical variable because we are splitting the intervals by a categorical variable, so we need to provide that. So my categorical variable at this moment is the geocode, which is my geological log. And similarly to what I did above, I'm gonna look at the tail values for my split composites. So if I run this, it's gonna show me now the result of this function. So what we can notice here is that every time a domain has changed codes, we break the composites. So this composite's 5 meters, this is 5 meters, and this is not 5 meters, this is about 2.2 meters. And that's because the next composite, the next interval has a different geocode. So we are splitting at the contact of the different geocodes. So that's the goal of the split composites. There are more parameters to this function, and I recommend you to read carefully the documentation because you can do things like lump short intervals and define what is considered a short interval. So I do recommend reviewing the documentation on this function. We have calculated the intervals for our composites, And after calculating the intervals, we have to actually composite the data, which in this case is, for instance, calculating the average copper value within each one of these intervals. So let's move into that. In order to perform compositing, we are going to be using rmsp.comp, and there's the only function, composite. And the arguments for this composite are our raw assays, which we are going to be using our merged assay, and we are going to use the split composites. One thing about this that you may notice is that we have composite here, we have geocode in this data, and we also have geocode in this data. Where is it? Yes, geocode is there. So we have geocode in both data, and we don't want to repeat the variable. So I will keep the geocode from my raw assays. And for my composite intervals, what I can do to ignore my geocode is actually to just get my metadata. That's all that matters. So I can do get meta slice. When I do get meta slice, I omit the column that's not metadata, so that doesn't go into the compositing. So I'm going to copy this over to my function and remove some of the cells that I'm not going to use. And basically, these are the two information that's required for composite, or raw assays and the compositing intervals. If I inspect the documentation of this function and go to the very end, I can see what it returns. It returns a dictionary, and it also returns the composited interval. So this function returns two things, and we want to capture both in different objects. So the first one was a composite dictionary, so we're going to call it comps.dict, and the second one was the composites intervals. And we can capture that result. So compositing has completed. If I look at the composited dictionary, what it has is just the information for each one of the columns that have been composited. It tells me if it used any weights. In this case, I haven't specified any weights to be used within the composite, so it returns none. And it tells me what method it used for compositing. So we expect that grades and such are averaged arithmetically, and we expect that categorical data are not averaged arithmetically, but with the majority rule. So it just tells me the largest interval of certain category for that composite is what defines what the final value of that composite is. So it's always good to check if the composite dictionary matches our expectation, because some of these are assumed internally based on the type of each column of your data frame. So if something returns differently than you expect, you can actually provide this to the function. So let's copy this above. And also what we can do is to display this table, and we just want to display the first element. So if I copy it over here, now I can have both outputs into the output of running that cell. So I have the head of the composited intervals. You can see all the elements, and I have the dictionary here for me to check. One thing that I would like to note as well is that this function, the composite function, is going to create some new columns for each variable, which is called length. So basically, this length is telling me what is the length within that composite that has none missing value for a given variable. So for instance, from 0 to 5, everything for density was missing. So it tells me that the actual length of density within this composite was 0. If I had a very short composite, it would return a very short length. So that's useful information as well. And the other thing that it returns is the geocode, because that's part of the merged assay that I provided to the function.